Hi everyone, welcome to today's GCSE Maths revision video. There's 2 days to go to your GCSE Maths exam, so it's not tomorrow, it's the day after. So keep up the hard work, you're doing really well, you're getting there. And today we're doing the last of our recap videos, and today we're going to be focused on the geometry or the shape, space and measures topics, so things such as Pythagoras' theorem and things like that. So in today's video we're going to be doing a recap of those topics. It might be useful for you to get a piece of paper and to jot some of the stuff down just to make sure that you remember it. Alternatively, just sit back and watch the video and just make sure you're confident with all the topics that we're going to be going through in terms of the geometry or the shape, space and measure topics. So let's get started. Hi, today we're going to do a recap of the shape, space and measures topics, or the geometry topics from the Corbettmaths Revision Checklist, the GCSE Foundation Revision Checklist, and then the topics in green. If you want a bit more detailed explanation, if you go to the Ultimate GCSE Foundation Revision video from 2 hours 38 minutes and 1 second until 4 hours 55 minutes and 40 seconds, I go through those geometry or shape, space and measures topics. So in this video we're going to go through all these topics. So let's get started. So let's begin with angles. It's important you know the types of angles. So we've got our acute angles between 0 and 90 degrees. We've got the right angles, they're 90 degrees. We've got obtuse angles, they're bigger than 90 but less than 180 degrees. And our reflex angles, bigger than 180 degrees but less than 330. In terms of your angle facts, you need to know that angles in a right angle will add to 90 degrees. Angles in a straight line will add to 180 degrees. And angles at a point will add together to be 360 degrees. Also, it's important that you know how to measure and draw angles. So make sure you've got your protractor in the exam. Make sure you know how to use that to measure and draw angles. You might be given a question where you're asked to draw an angle or measure an angle, but it might also come in useful whenever you're drawing pie charts and measuring bearings and things like that. Next, angles and parallel lines. So make sure you know the different types of angles whenever you're dealing with parallel lines. So here we've got our alternate angles. Make sure you call them alternate angles and not Z angles, but they're alternate angles there and there. They're the same as each other. Corresponding angles are equal to each other as well. So the bottom right here and the bottom right, or the top right and the top right, top left and top left, bottom left and bottom left. So they would all be corresponding angles to each other and they're equal to each other. Also, whenever you're dealing with parallel lines, you may encounter co-interior angles. So this angle and this angle will add together to be 180 degrees. So if you've got co-interior angles, they add together to be 180 degrees. And vertically opposite angles, if you've got two straight lines that cross each other, the opposite angles will be equal to each other because they're vertically opposite. So this is 135 and this is 135 and this angle is 45 degrees and that angle is 45 degrees. So it's important to know those alternate corresponding co-interior and vertically opposite angles. So we've looked at angles at a right angle, angles in a straight line, angles at a point. Now we're going to look at angles inside of shapes. So the angles inside of a triangle will always add together to be 180 degrees. So if we wanted to find the size of this angle, we would add the two angles that we've been given and take that away from 180 degrees to find the size of this one. Also look out for the special triangles. So an equilateral triangle, all the angles are the same, they're all 60 degrees. If you've got isosceles triangles, remember they've got a line of symmetry, so two angles will be the same. So if that's 63, that's 63. And if we wanted to find the size of y, we'd add those two together and take it away from 180 degrees. So make sure you know that the angles in a triangle add together to be 180 degrees. Next, angles in a quadrilateral. So if we've got a four-sided shape, such as this quadrilateral, the angles will add together to be 360 degrees. Okay, so we've looked at the angles in a triangle and the angles in a quadrilateral. The angles in a pentagon add up to be 540 degrees, and I tend to learn that off by heart. The angles in a hexagon add up to be 720 degrees, and again, I tend to learn that one off by heart. And then I learn every single side that we're adding. We're adding another 180 degrees to the sum of the interior angles. So for a heptagon, we just add another 180 degrees. For an octagon, we add another 180 degrees, and so on. And you can use this formula that if you take the number of sides and take away 2, and then multiply that answer by 180, you get the sum of the interior angles. So for instance, for an octagon, I would do 8 take away 2, which is 6, and then times 180, which is equal to 1080. And some other useful information whenever we're dealing with polygons is that the sum of the exterior angles will always be 360 degrees. So no matter how many sides the polygon's got, all the exterior angles, all these red angles will always add together to be 360 degrees. Another useful bit of information is that the interior angle and an exterior angle will always add together to be 180 degrees. So if I know that this is 72 degrees, I can find the size of the interior angle. I would do 180 minus 72, and that's equal to 108. And that's it. Okay, so let's have a look at a typical question. It says, work out the size of each interior angle of a 12-sided regular polygon. So it's a regular polygon, so that means all the angles are the same size, and it's got 12 sides. Now there's two different ways you can approach this. One is you could take 12 and then take away 2. That's equal to 10 and multiply that by 180. So that's going to be equal to 1,800 degrees. So that's the sum of the interior angles in a regular 12-sided polygon. And then if I take the 1,800 and divide that by 12, that's equal to 150 degrees. So that means each one of the interior angles in this regular 12-sided polygon will be 150 degrees. Now there is also another approach, because we know that all the exterior angles always add together to be 360, we could do 360 divided by 12, and that's equal to 30 degrees. So each one of the exterior angles is 30 degrees, and then we could do 180, take away 30, and that's equal to 150 degrees. And that's it. So that's some useful information whenever you're dealing with angles and polygons. Okay, next, let's have a look at bearings. So bearings are a direction of travel measured clockwise from north. So if, for instance, I wanted to find the bearing of Castletown from Milton, what I would do is I'd first of all join up Castletown and Milton, like so. I would then draw a north line at Milton because we want the bearing from Milton, so I'd draw the north line at Milton, like so. And then I want to measure the size of the angle clockwise from north until that line we've drawn, so I'd want to measure the size of that angle. I then get my protractor, I'd measure the size of that angle. Let's pretend it's equal to 40 degrees. So if that angle was equal to 40 degrees, then the bearing of Castletown from Milton would be 040 degrees. Always make sure the bearings have got 3 digits, so if it's less than 100, make sure you put that 0 in front of it. So that's how you measure bearings. If I wanted to find the bearing of Milton from Castletown, I would draw a north line at Castletown, and then I'd measure the size of that reflex angle going clockwise from north all the way around to here. And I'd measure the size of that angle, and that'll be the bearing of Milton from Castletown, and that's it. Now it's also important to be able to work out back bearing. So the bearing of Nottingham from Dublin is 098 degrees. What's the bearing of Dublin from Nottingham? So that's finding the bearing going the other way. Now you could do that doing little sketches and stuff, and that's fantastic. But a bit of a shortcut is if it's less than 180 degrees, you can just add 180 degrees, and that'll tell you the back bearing. And if the bearing that you're given is 180 degrees or larger, you then take away 180 degrees. So if I wanted to find the bearing of Dublin from Nottingham, I can just take 098 and add 180 degrees, and that's equal to 278 degrees. So that would be the back bearing, it would be the bearing going the other way. You could show it using a sketch as well. And your sketch would look something like that, where you've got Dublin, you've got Nottingham, you've got your 98 degree angle, joining them up. You then use your co-interior angles, they add together to be 180 degrees, so you can find the size of that one, and then take that away from 360 to find the size of that angle, and then that would be the back bearing, the angle measured clockwise from north. And that's it. Next, it's also important that you know how to deal with scales and maps. So know your compass directions, north, east, south and west, and also know in between those being northeast, southeast, southwest and northwest. So know your compass directions. Whenever you're dealing with scales and maps, make sure you read the scale. So for instance, 1 centimeter is 30 miles. So if for instance I wanted to find the distance between these two towns, if I measured it and perhaps it was equal to 7 centimeters on the diagram, I would then do 7 multiplied by 30, and that's equal to 210. So that means that in real life they would be 210 miles apart from each other. So make sure you know how to deal with those scales and maps. Okay, another important topic is perimeter. So you might need to be able to find the perimeter of a shape. So remember, the perimeter of the shape is the distance around the outside. So if I wanted to find the perimeter of this rectangle, I would do 6 plus 20 plus 6 plus 20. And whenever I'd add those all up, I would get 20 plus 20 is equal to 40, plus 6 is 46, plus 6 is equal to 52. And I would show that by doing this. And also make sure that you show your method whenever you find the perimeter of shapes. So to find the perimeter of a shape, you add up the distances around the outside of the shape. So that's how you find the perimeter of a rectangle. If you've been given the perimeter of the rectangle, and for instance you wanted to find the size of the width, what you would do is you'd add together the two lengths, take that away from the total perimeter, and then half it, and then that would tell you the size of each one of the widths. Here we've got an isosceles triangle. If we wanted to find the perimeter of this, I would know that that's equal to 7 centimeters because these two sides have got the same length, and then I would just do 10 plus 7 plus 7, which would be 24 centimeters. And that's it. So make sure you know how to find the perimeter of the shape, adding up the distances around the outside. Next, area of a rectangle. So it's important that we know how to find the area of a rectangle and the area of a square and so on. So to find the area of a rectangle, we just do the length times the width. So the area is equal to the length multiplied by the width. So we just do 9 times 5, and 9 times 5 is equal to 45 centimeters squared, and make sure you get the right units. If it's centimeters and centimeters, the area will be centimeters squared. Here it's a square, that means the length is 7 and the width is 7, so you just do 7 multiplied by 7 is equal to 49 centimeters squared, and that's it. So make sure you know how to find the areas of rectangles and squares and things like that. Also, it's important that we know how to find the area of a triangle. So the area of a triangle is found by doing half the base times the height. So you can do the base times the height. So in this case, 14 times 5 is equal to 70. And then you get half it to be 35 centimeters squared. Or you could half the base first of all. So half of 14 is 7. And then do 7 times 5 is 35 centimeters squared. You could even half the height, which is 2.5, and then times that by 14, which would be 35 centimeters squared, and so on. So you just do the base times the height and then make sure that you half it. Also, in terms of a parallelogram, if you're given a parallelogram and you want to find its area, you just do the base times the height, the perpendicular height. So if I wanted to find the area of this parallelogram, I would just do 11 times 5. You ignore any lengths of the diagonals. You just do the base times the height, the distance between the two sides. So the area is equal to the base times the height. Okay, next, area of a trapezium. Sometimes you might need to be able to find the area of a trapezium, such as this shape here. And if we wanted to find the area of a trapezium, the formula is a half a plus b multiplied by h. In other words, you add together the lengths of the two parallel sides, first of all. You then half that, so 7 plus 11 is equal to 18. You half that to 9, and then times by the height, the distance between them. 9 times 5 is equal to 45, so that'll be 45 centimeters squared. And that's it. So use this to find the area for trapezium, half brackets a plus b times h. And that's given to you. So if you need a bit of a recap and finding the area for trapezium, go to the formula sheet and you can find it. But if you remember it, fantastic. Okay, next. Sometimes you may encounter compound shapes. So they're shapes formed by joining other shapes together. So if I wanted to find the area of this shape, for instance, I would divide it into a rectangle and a triangle. I would do the length times the width to get the area of the rectangle. In terms of the triangle, I would get the base and the height, the distance between the base and the highest point. And I would do the base times the height and then half it. And then I would add them together. And then if I had this L shape, I would just divide it. I could divide it that way or that way and just find the area of this part and then add them together. It's also very important that you know your unit conversions as well. And so for instance, 1 kilometer is 1,000 meters, 1 meter is 100 centimeters, 1 centimeter is 10 millimeters, and so on. Also know that 1 liter is 1,000 milliliters and that 1 liter is 1,000 centimeters cubed. So they're quite useful as well. And then in terms of your mass, how heavy things are, 1 ton is equal to 1,000 kilograms and that 1 kilogram is equal to 1,000 grams. So feel free to press pause and to write these down. Also, you may be asked to make sensible estimates. So for instance, they might have a picture of a man beside a building and they might ask you to estimate the height of the building. So by considering some everyday objects around you, for instance, the height of a person is roughly about 1.8 meters, or the length of my local swimming pool is about 25 meters, it just gives you a sense of how long things are. Or for instance, knowing that a big bottle of Fanta here is equal to 2 liters, or if it's a smaller one, it might be 500 milliliters and so on. That a bag of sugar is 1 kilogram. If you do weights, you might know how heavy the weights are and so on. So knowing roughly how long things are and how heavy things are and how much things hold around you might be quite useful whenever you're dealing with those sensible estimates. Okay, next, line symmetry. So make sure you know your lines of symmetry. So for instance, an isosceles triangle's got 1 line of symmetry. A rectangle's got 2 lines of symmetry, that vertical one and horizontal one. It doesn't have any diagonal lines of symmetry because if you do the diagonal one, it wouldn't fold over properly. So it's got a vertical line of symmetry and a horizontal line of symmetry. A square's got 4 lines of symmetry. A parallelogram doesn't have any lines of symmetry. An equilateral triangle has 3 lines of symmetry. A regular hexagon has 6 lines of symmetry, and so on. Okay, next, rotational symmetry. So rotational symmetry, if we rotate a shape through 360 degrees, how many times it lands on itself is its order of rotational symmetry. So for instance, this rhombus, if we turn it through 360 degrees, it lands on itself once, and then again twice. So the order of rotational symmetry for this rhombus would be 2. Here we're asked to circle the shape that's got order of rotational symmetry 4. So the order of rotational symmetry for the heart is 1. For the square would be 4, it would land on itself 4 times, so we'll circle that. The star would be 5, and the isosceles triangle, the order of rotational symmetry would be 1 there. And that's it. Constructions, make sure that you're able to construct the angle bisector, the perpendicular bisector, and so on. These videos will be useful for those. And these diagrams probably just give you a bit of a recap in terms of how to do it. So for an angle bisector, you'd get the point of the compass here. You then do an arc here and here, making sure the compass stays the same size. Then you put the point of the compass here, you do an arc towards the middle somewhere, and then you keep it the same size and put the point here and do an arc towards the middle somewhere. And wherever they cross, you just draw a line through that, and then that would be the angle bisector. We'd cut the angle in half. And then for the perpendicular bisector, just set it over halfway the length of the line. So put the point here and set the pencil over here somewhere. Do an arc above and below. Keeping the compass the same size, put the point on the other side and do another one above and below. And then you just join up where they cross, and then that's going to be the perpendicular bisector. So make sure you know how to do those constructions, and these videos will be useful. Okay, next you may encounter loci questions. So remember, that's perhaps showing on a diagram particular regions that would satisfy some rules. So here we've got a boat is within 8 miles of A and 5 miles of B. I've been asked to shade the possible positions of the boat, and we've got the 1 centimeter is equal to 1 mile. So what you do is you'd get your compass, you'd set it to 8 centimeters in terms of the distance, the radius of that circle. You'd put the point on A, and then you do an arc. Now I'm guessing the boat's at C here. I should have already said that in the question. And then you do your arc going around. Then you'd set it to 5 centimeters and then put the point on B, and then you'd do an arc as well. And because it's within 8 miles of A and 5 miles of B, the regions that are within both of those then would satisfy that. Now you would shade that, and that would be the possible positions of the boat. It might be useful with loci to watch these videos and to try the practice questions. They'll be handy as well. Okay, next 2D and 3D shapes. So you may need to name shapes on your exam, so it's important to know the names of the different 2-dimensional shapes. So press pause if you need a bit of a recap of these. So make sure that you know the names of these 2-dimensional shapes. Also, make sure that you know the different types of triangles. So for instance, your right angle triangle, your isosceles triangle, so where 2 sides are the same length and where 2 angles are equal to each other, and it's got 1 line of symmetry. An equilateral triangle, it's got 3 lines of symmetry, and all the sides have got the same length, but each of the angles is 60 degrees. And a scale scalene triangle. So that's a triangle where all three sides are different lengths and all three angles are different sides as well. And likewise, make sure you know the names of the quadrilaterals. So your square, rectangle, rhombus, trapezium, parallelogram, kite, and so on. So make sure you know the different quadrilaterals and their properties. Also, you have three-dimensional shapes such as your cube, your cuboid, your sphere, your cone, your cylinder, your triangular prism, your square-based pyramid, your other prisms, and so on. So make sure you know the different types of three-dimensional shapes and also their properties, such as how many vertices do they have. So for instance, in terms of vertices, remember they're the corners. One of them is called a vertex, and the plural of that's vertices. So here we've got a cube. It would have 8 vertices, 4 on the top, 4 corners on top, 1, 2, 3, 4, and 4 on the bottom, 1, 2, 3, 4. So it would have 8 altogether. Faces. So this cube would have 6 faces, and just think of a dice in terms of the faces, how many faces it's got, 6. And also you make sure you know what edges are, so they're the lines that join the vertices. Okay, next. Also make sure you know the nets of the three-dimensional shapes. So the net of the cube, the net of the cuboid, the net of the square-based pyramid, being that square with those 4 triangles that would fold up to the top, the triangular prism net, the net of a cone, and the net of a cylinder, and so on. So make sure you know your different nets as well. Also, parallel lines. So parallel lines are lines that never meet each other. So these two lines are parallel, they never cross. And lines that are perpendicular, so they do cross, and they cross at 90 degrees. So these two lines would be perpendicular to each other. So be able to recognize and label and so on parallel lines and perpendicular lines. Okay, next. Views and elevations. So if you've got a shape and we want to draw the different views, the view from the front is called the front elevation. So the view from the front is called the front elevation. The view from the side is called the side elevation. It can be from that side or that side. So you've got the side elevations, the view from either of the sides. And the plan view is the view from the top. So make sure you can draw the front elevations, the side elevations, the plan view, and so on. Also, make sure you're confident with dealing with time calculations. So here's a question. It says Ella finishes school at 3 p.m. The time on her watch is 13:14. So obviously here we've got 12-hour clock and 24-hour clock. So with the 24-hour clock here, 13:14 would be 1:14 p.m. So that's 1:14 p.m. And the question is, how many minutes is it until Ella finishes school? So whenever you're dealing with time calculations, it can be quite useful to consider a bit of a timeline. So that's my sketch of a bit of a timeline here. So we've got the time now is 1:14 p.m. We want to find how long it is until we get to 3 p.m. So I'd probably want to go to 2 p.m. first of all. So to go to 2 p.m., that would be 46 minutes. So 46 minutes. And then it'd be another hour until 3 p.m. So it's another hour. So it'd be 1 hour and 46 minutes. So that's how long it would be. Now the question is, how many minutes is it? So make sure that then you change this into minutes. So an hour, 60 minutes. So that'd be 106 minutes altogether. So make sure you can deal with those time calculation questions. And I usually find a bit of a timeline helps me. Also, timetables. You may encounter timetables for buses or trains and so on. So here, this is a timetable. We've got 1, 2, 3 buses here. This is a bus timetable. So there's 1, 2, 3 buses. Each of the columns represents one bus. Each of the times represents when the bus arrives and leaves by. So if you're in Milton and you wanted to catch the bus, you would want to make sure that you're there before 9:41 because that's when the bus would arrive and leave by. So you want to make sure you're there for that time. And then it should arrive in Newtown at 9:49, Red Island at 9:55, and so on. This is an express bus. It only goes from Southville to Red Island to Bakerstown. It doesn't stop at the stops with the dashes in it. And be prepared to answer questions like, how long would the journey take to get from Leek to Sandville? Or for instance, Bob's in Milton at 10:30 and he wants to catch the bus to Sandville. How long will he have to wait until the next bus? And questions like that. So make sure you're confident with dealing with different questions that you may encounter whenever you're dealing with timetables. Okay, next. Now distance charts can look a bit different depending on how they're set out, but this is a distance chart. And in terms of reading it, if I wanted to find out the distance between Leek and Bilton, I'd go to Leek and then go across to where it meets the Bilton column, and then that would be 23. So 23 miles or kilometers depending on what you're told in the question, and so on. So make sure you can deal with those distance charts. Okay, next. Speed, distance, and time. So speed is found by doing the distance divided by the time. And make sure that if, for instance, you're dealing with miles per hour and you've got 1.5 hours, make sure you're doing 1.5 for the time. Or if it's 2 hours and 15 minutes, it's 2.25 hours. That's going to be 2.25 and so on. So make sure you know how to do speed is distance divided by time. Distance is equal to speed times time, and time is equal to distance divided by speed. And I often just remember this by remembering what speed is, miles per hour. So for instance, if it was 30 miles per hour and I traveled for 4 hours, I would just do 30 times 4, and that's equal to 120. Some students may use this to remember it, which is a triangle. And if you wanted to find speed, you'd put your finger or cover up speed and you'd do distance divided by time. If you wanted to find time, you'd cover up the time, you'd do distance divided by speed. And if you wanted to find distance, you cover that up and you do speed times time. However you remember it with 2 days to go and you're doing speed, distance and time, just remember it however you normally approach it and you'll be fantastic whenever you answer these questions. Travel graph. So here's a travel graph. It's a distance time graph, and some questions that you may encounter with travel graphs might be to work out speeds for particular sections of the journey. So what was the speed between 8 o'clock and 9 o'clock, and just remember to do distance divided by time. You might be asked, for instance, what happens between 9 o'clock and 9:15, and because the line's flat, that means that the person is stationary, they're not moving for that 15 minutes there. Also, you may encounter questions, for instance, which part of the journey was the person traveling the fastest, and then you're going to want to look for the steepest line and so on. Okay, density. So the density is measured in grams per centimeter cubed or kilograms per meter cubed, and we can calculate it by doing mass divided by volume. We can calculate the mass by doing density times volume, and we can calculate the volume by taking the mass and dividing it by the density. So that's how you'd approach density questions. They're quite often linked with volume questions. You might need to find the volume of a certain shape, a certain 3D shape, and then you can find perhaps the mass of it by multiplying the volume by the density and so on. Some students may use a triangle to remember density, so they would draw this triangle with a D, an M and a V, and if for instance you wanted to calculate density, you'd cover it up and do mass divided by volume. If you want to calculate volume, you do mass divided by density, and if you want to calculate the mass, you do density times volume. Obviously with this stage with 2 days to go, use whatever approach that you're confident with whenever you're dealing with density. Okay, next, pressure. So pressure is found by taking the force and dividing it by the area, and we can calculate the force by doing pressure times area, and the area can be found by taking the force and dividing it by the pressure. And again, if you use a triangle, it would look something like this, and you would have P, F and A, and if you wanted to work out the pressure, you cover up the P and you do force divided by area. If you want to find the area, you do force divided by pressure, and if you want to find the force, you take the pressure and multiply it by the area, and that's it. And again, with 2 days to go, use whatever approach you're confident with whenever you're dealing with pressure. Okay, next, translations. So there's different transformations that you may encounter in GCSE maths. So one is a translation, that's where you slide a shape. So we're going to slide this shape, and we've been asked to translate by this vector. This is a vector, and we've got -1, 5. The number at the top tells you how many squares left or right to translate it. If it's negative, it means to the left. If it's positive, it means to the right. If it's 0, it doesn't move left or right. The number beneath that would be how many squares up or down. If it's positive, that'll be up. If it's negative, it'll be down. If it's 0, it doesn't move up or down. So this vector is telling us to move this shape 1 square to the left and 5 squares up. And that's it. We've translated shape C by -1, 5, and make sure you know what those vectors mean. The top number is how many left or right, negative to the left, positive to the right, and the bottom number is up or down, positive up, negative down. Okay, next, reflections. So in terms of reflecting shapes, you may be asked to reflect something in the x-axis or y-axis. So if, for instance, we're asked to reflect this in the y-axis, we would choose a point, for instance this one. It's 1 squared to the y-axis, so we then go in of 1 to there. This point here is 1, 2, 3 to the y-axis, so we go 3, 1, 2, 3 to here. And this point is 1, 2, 3 to the y-axis, so we go over 3, 1, 2, 3. And then you just join them up, and that'll be that shape C reflected in the y-axis. If it was the x-axis, you would do the same, but you would count down to the x-axis. You might also be asked to reflect it in lines such as x equals -1, and then you draw the line of x equals -1. So that's the line x equals -1, and again you just choose each of the points and you just go 1, 2 to the line, 1, 2, and so on. If it was y equals 1, perhaps you draw the horizontal line passing through 1 on the y-axis. So then you'd reflect that triangle and that line and so on. So it's important to know those lines, those x equals lines and those y equals lines. And you may also be asked to reflect a shape in the line y equals x or y equals -x. So just know that the line y equals x would look like this. So that's the line y equals x. It would look something like that. Just the diagonal line passing through 0, 0, 1, 1, 2, 2, -1, -1, and so on. And that's the line y equals -x. For instance, 1, -1, 2, -2, -1, 1, and so on. So that's the line y equals -x. And if we wanted to reflect this in that line, we choose a point and we just count the diagonals. 1 diagonal and a half. So it's 1 1/2 diagonal. So we go 1/2 and 1. So it'd move to there. This point is 1, 2 and a half. So we go 1/2, 1, 2 to there. And this point up here would be 1, 2, 3 and a half diagonal. So we go 1/2, 1, 2, 3, and it'd move to there. And then just join those up. Okay, next, rotations. So in the exam, you're entitled to tracing paper. So put up your hand and ask for tracing paper in the exam. You might want to ask for it at the very beginning before it even begins, just so you've got your tracing paper on your desk. And if we wanted to rotate this rectangle 90 degrees anti-clockwise about the point 2, -1, the first thing I would do is I'd plot that center of rotation 2, -1 on the grid. So 2, -1 is here. I would then get my tracing paper and put it on top of that, like so, and I'd make sure that it's either landscape or portrait. Then what I would do is I would trace over the center of rotation and the rectangle. Then I'd get my pencil and put it on top of the center of rotation and gently rotate the paper, the tracing paper, 90 degrees anti-clockwise. Remember that anti-clockwise is that way and that clockwise is that way. And if you need a bit of a hint, look at the clock in the exam hall and think which way is clockwise, the way the hands on the clock go, and which way is anti-clockwise. And then you just get your tracing paper and you rotate it. And then you just rotate the tracing paper 90 degrees anti-clockwise. And it was landscape and now it's portrait. And then you just draw that rectangle on that position on the grid. And that's it. Okay, in terms of enlarging shapes, we've been asked to enlarge B by scale factor 2 using 4, 3 as the centre of enlargement. So 4, 3 would be there. Each of these points are going to become twice as far away from the centre of enlargement. So this point here is 1, 2, 3 to the left. So we're going to go 6 to the left. 1, 2, 3, 4, 5, 6. That's going to move to there. This point is 1, 2 to the left. So we're going to go 4 to the left. 1, 2, 3, 4. This point down here is 2 to the left and 2 down. So we're going to go 4 to the left and 4 down. 1, 2, 3, 4. And this point here was 3 to the left and 2 down. So we're going to go 6 to the left and 4 down. So 1, 2, 3, 4, 5, 6 and 4 down will be there. And then we just join that up. And that's how you enlarge a shape on a grid. Okay, next the parts of the circle. So we've got the radius from the center to the edge of the circle, the diameter the whole way across the circle for the center, the circumference of the circle the whole way around the outside of the circle, the chord joining one part of the circle to another part of the circle, an arc which is part of the circumference, a tangent, a line that just touches the circle and carries on. Okay, next the sector. So I like to call that the pizza slice. We've got a radius, an arc and a radius. That's a sector, that region inside. And then finally a segment. So that's where you've got a chord and an arc, and that region inside of it, bounded inside, is the segment. And that's it. So it's important you know those parts of the circle. So in terms of circumference is pi times diameter. So if you multiply the diameter of the circle by pi, you get the circumference. So if I wanted to find the circumference of the circle, I would just do pi multiplied by 14. And if it's a calculator question, I would just do that on my calculator and get my answer, and that'll be so many centimeters. If it was a non-calculator question, instead of doing it on my calculator, I would just write 14 pi centimeters. And that's it. You just put them together and put the number in front. But if it's a calculator question, just type it into your calculator, press equals, and that'll be the circumference of the circle. If you want to find the area of a circle, you do pi r squared. So here we've got a circle with radius 6, so I would do pi multiplied by 6 squared. If it's a calculator question, I would just type in pi times 6 squared on my calculator, and then I'd press equals, and what I get in my calculator would be the answer. And then I'd make sure that I use the right units, which would be centimeters squared. If it was a non-calculator question, I have to square first. Remember the order of operations, 6 squared is 36. So the answer would be 36 pi centimeters squared in a non-calculator test. And that's it. You may also need to be able to find the perimeter or areas of semicircles and quarter circles. So if I wanted to find the area of these, for this one, I'd find the area of the whole circle. I would do pi times 3 squared, get the area of the whole circle, and then just half it, and that'll be the area of that semicircle. If I wanted the area of this quarter circle, I would turn it into a whole circle. I would do pi times 15 squared, because for the whole circle, 15 is the radius. So I do pi times 15 squared to get the area of the whole circle, and then just divide it by 4, and that'll be the area of that quarter circle. If I wanted to find the perimeter of this semicircle, what I would do is I would turn it into a whole circle. I would do pi times diameter, so the diameter of the whole circle is 6, so I would do pi times 6 to get the circumference of the whole circle, and then half that, and that would tell me that distance, that arc length there, from there around to there. And then I would just add on 6, the length for that side, and then that would be the perimeter of that semicircle. And for this quarter circle, I would turn it into a whole circle. I would do pi times diameter, which is pi times 30, so that'll be the circumference of the whole circle. And then I would divide that by 4 to find the length of that arc. And then I would just add on 15 and 15, and that'll be the perimeter of that quarter circle. If you're given a sector that's a little bit trickier than a quarter circle or semicircle, you might want to use this formula. So if you want to find the length of that arc, you would take the number of degrees, you would divide it by 360, because that's the fraction of the circle, and then times it by the circumference, which is pi times diameter. And then that will tell you the length of that arc. So if you take this angle, put it over 360 and multiply by pi, and then the diameter of the whole circle, which would be 16. That'll tell you the length of that part, that arc. And then if I wanted the perimeter of this sector, then add on 8 and add on 8. And then that'll be the perimeter of that sector. And likewise, for the area, we take the fraction of the circle. So we put the angle over 360, so 109 over 360. And then multiply by the area of the circle. You do pi r squared, so pi times 0.7 squared. And then multiply that by 109 over 360. And then that'll tell you the area of that sector. Okay, make sure you know Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared equals c squared. So the two shorter sides, you label them a and b, and the longest side, the hypotenuse, you label that c. And then you write down Pythagoras' theorem, which is a squared plus b squared equals c squared. And then you replace a, b, and c by their values. So a was 5, so we've got 5 squared plus b squared, which is 12 squared, equals c squared, which is x squared. 5 squared is 25, plus 12 squared is 144, equals x squared. When you add these together, you get 169 equals x squared. This side is obviously not equal to 169 centimeters. That's x squared. So we then square root that. So x is equal to the square root of 169, which is equal to 13. So x equals 13 centimeters. And that's it. That's the length of that side. So make sure you know Pythagoras' theorem, a squared plus b squared equals c squared. And it can be quite useful whenever you've got triangles like so, but also if you're asked to find the length of diagonals and rectangles and things like that. Have a go at the practice questions as well, they're quite useful. Okay, so with trigonometry, you need to make sure you know your trig ratios. The sine of an angle is opposite divided by hypotenuse, the cos of an angle is adjacent divided by hypotenuse, and the tan of an angle is equal to the opposite divided by the adjacent. I remember them as two old angels, skipped over heaven carrying a harp. Some people remember staccato and so on. So you need to make sure you know those trig ratios. And some students may use these triangles. So for instance, if you want to find the sine of an angle, you do opposite divided by hypotenuse. If you wanted to work out the adjacent here, you do the cos of the angle multiplied by the hypotenuse and so on. And with 2 days to go, use whatever approach that you like the best. And now, if for instance, if we wanted to find the sides of this angle, using trigonometry, we would label the sides. Opposite the right angle is the hypotenuse. Opposite the angle is the opposite, and the other side is the adjacent. In this question, we're using the adjacent and hypotenuse, so we're not using the opposite, so we can cross that off. So we're using adjacent and hypotenuse. That's going to be cos. That's the cos of the angle. Cos x equals adjacent divided by hypotenuse. And you can remember that either by knowing your trig ratios or by knowing your triangles. So you can write down the cos of the angle is equal to the adjacent divided by hypotenuse. Now let's substitute in the values. The cos of the angle is equal to the adjacent, which is 8 divided by the hypotenuse, which is 10. The size of this angle obviously isn't equal to 8/10 of a degree, so we need to do the inverse cos. So x is equal to the inverse cos, the cos of little minus 1, of 8/10. And whenever you type that into your calculator, you get the answer. And that's equal to 36.87 degrees. And that's it. So trigonometry, just make sure you label the sides, you cross off the one you're not using, you write down the trig ratio that you need to use in the question, you substitute in the values, and then you just solve it to find x. Likewise, you can use it to find the length of a side. So here we've got a right angle triangle again. Let's label the sides, the hypotenuse, the opposite, and the adjacent. In this question, we're not using the adjacent, so we cross that off. So this time we're using the opposite and the hypotenuse. So that's going to be sine, the sine of the angle. So sine vita is equal to the opposite divided by the hypotenuse. Now we're going to substitute in our values. The sine of the angle, so the sine of 60 degrees is equal to the opposite, which is x, divided by the hypotenuse, which is 4. We want to solve this to find x, so we're going to multiply both sides by 4. So we're going to multiply by 4 and multiply by 4. On the right hand side, we multiply by 4 to get rid of the divided by 4, so we're just going to be left with x. And on the left hand side, we have the sine of 60, so the sine of 60 times 4. And whenever we do the sine of 60, close brackets, times 4 in our calculator, we get that's equal to 2 root 3, or 3.464 kilometers to 3 decimal places, and that's equal to x. And that's it. So we've found the length of that side. And again, if you use the triangle, you would have done that triangle there. If you wanted to find the opposite, you cover that up. So you just do sine of the angle times the hypotenuse, and that's it. So you just do sine of 60 times the hypotenuse 4, and that's it. Also, it can be quite useful to know your exact trig values. So obviously the sine of 0 is 0, the sine of 30 is a half, the sine of 45 is root 2 over 2, the sine of 60 is root 3 over 2, and the sine of 90 is equal to 1. The cos of 0 is equal to 1, the cos of 30 is equal to root 3 over 2, the cos of 45 is equal to root 2 over 2, the cos of 60 is a half, and the cos of 90 is equal to 0, and the tan of 0 is 0, the tan of 30 is root 3 over 3, the tan of 45 is 1, the tan of 60 degrees is root 3, and the tan of 90 degrees is undefined. It's the asymptote. Okay, next, similar shapes. So similar shapes are enlargements of each other. So if we were asked to find the length of this rectangle B, if we were told that these two rectangles are similar to each other, we can look at the two widths, because 12 divided by 4 is equal to 3, so it means it's 3 times bigger. So if we multiply the length by 3, so if we take 6 and multiply that by 3, that'll give us the length for the larger rectangle, which would be equal to 18 centimeters, and that's it. So whenever you're dealing with similar shapes, try and find the scale factor of enlargement, and then you can find out what the lengths of the missing sides would be. So we've looked at similar shapes. Congruent shapes are the shapes that are identical to each other, so the same shape and size. If you're dealing with congruent triangles, you might need to know some conditions to when they're congruent. So those would be side, side, side. So if you've got two triangles with all three of the same length sides, they're congruent, they're the same as each other. If you've got angle, side, angle, so an angle, a side, and an angle, and the same angle, side, and angle, they'd be congruent to each other. Side, angle, side, so if you've got a side and angle in between them and the other side, and the same with another triangle, they'd be congruent to each other. And if you've got a right angle, hypotenuse side, so in other words, you've got a right angle triangle, you've got the hypotenuse, the longer side, and one of the other shorter sides, then they would be congruent as well. Next, volume of a cuboid. So if we want to find the volume of a cuboid, the volume is equal to the length multiplied by the width multiplied by the height. So we would just take the length, which is 7, times the width, which is 2, times the height, which is 3. So we just do 7 multiplied by 2 multiplied by 3. And 7 times 2 is 14, times 3 is equal to 42, and then centimetres cubed, and that'd be the volume of that cuboid. So to find the volume of a cuboid, just do the length times the width times the height. You might also need to find the volume of a prism, and to find the volume of a prism, you find the cross-sectional area, so that's the bit that's constant through the shape, multiplied by the length. So here we've got this triangular prism, the cross-section is this triangle, and if we find the area of the triangle and multiply it by the length, we'll find the volume of the prism. So remember, for a triangle, we do half the base times the height, so we do a half of 7 multiplied by 5. A half of 7 times 5, well, 7 times 5 is 35, so a half of 35. And that's equal to 17.5 meters squared. That's the area of the front. Now to find the volume, we'll times by how long it is. So we just take our 17.5 and multiply that by 4, and that's equal to 17 meters cubed. And that's it. So to find the volume of this prism, we find the area of the cross-section, the triangle, and just multiply it by the length. Okay, you may need to find the volume of a cylinder, and using a similar approach, you just find the area of the circle and multiply by the height of the cylinder. So we would do pi r squared, we would do pi times 8 squared. We'd get that for the area of the circle, and then we just times it by 30. So that would be our answer. We would just get the area of the circle and times it by 30, and that would give us the volume of the cylinder. Okay, if you want to find the volume of a sphere, this formula is given to you. Just go to the formula sheet for the volume of a sphere, and it's 4 thirds pi r cubed. So we would just do 4 thirds multiplied by pi multiplied by the radius of the sphere, which is 14 cubed. And you can just type that into your calculator and work it out if it's a calculator question. If it's in a non-calculator test, what you do is you get the radius and you'd cube it. I'm guessing it'd be quite a bit of a nicer number than 14, so you'd cube whatever number it is. You'd work out 4 thirds of it, and then you just put it in front of pi, and then that would be your answer. And that's it. So make sure you know how to find the volume of a sphere. Remember, the formula is given to you and you just need to substitute in the value. And if it's on the calculator paper, you can just type it in. And also make sure you put down the right unit. So here it would be centimeters cubed. Okay, next, the volume of a cone. So the volume of a cone again is given to you. It's a third pi r squared h, where r is the radius of the base and h is the height of the cone. So you can just substitute those in and find that in the calculator test. So you just do a third multiplied by pi multiplied by the radius of the base, which is 20 squared, multiplied by the height of the cone, which is 21. And you can just type that into your calculator and work it out. And that's it. And so the volume of a cone is a third the area of the base, so a third the area of the circle, multiplied by the height. And that's it. And if it's on a non-calculator paper, you just need to work out this part. You square the radius and times it by the height, and then you just divide it by 3, and then just put the pi after it, and that'll be the volume of the cone on a non-calculator test. Surface area. So in terms of surface area, remember, surface area is the area of all the faces. So if I wanted to find the surface area of this cuboid, I'd find the area of the top, I'd find the area of the bottom, I'd find the area of the right hand side, the area of the left hand side, the area of the front, and the area of the back. I'd get those 6 areas and then add them all up. Now the great thing is the top's going to be the same as the bottom, the front's going to be the same as the back, the right hand side is going to be the same as the left hand side. So for here I would do 5 times 7 is 35 centimeters squared. The front would be 8 times 5 because the height of it is 5. 8 times 5 is 40 centimeters squared. And the top, it's going to be 8 times 7, that's 56 centimeters squared. So I know the top, the front, and the right hand side. So that means that we just do the top, the bottom, the front, the back, the right hand side, and the left hand side. And then if we just add them all up, that'll be the total surface area. And remember to be in centimeters squared here for the surface area. Also, you might need to find the surface area of a sphere. And again, that formula is given to you, 4 pi r squared. So you just do 4 multiplied by pi multiplied by the radius, which is 5 squared. On a calculator paper, you just type it into the calculator. Non-calculator paper, you just work it out and just put the pi after it. And that's it. And remember, unit centimeters squared. Okay, next, surface area of a cone. So in terms of surface area of the cone, if you're asked to find the total surface area of the cone, you're going to need to work out the curved surface area on the top and also the area of the circle on the bottom. Now you're given the formula for the curved surface area on the top, so you do pi RL. That's pi multiplied by the radius of the base, which is 6, multiplied by L, the length of that diagonal. You do that and that'll give you the curved surface area. And then you then also need to work out the area of the circle on the bottom. So you do pi times 6 squared to find the area of that circle and then add them up. And that's the total surface area of the cone. Okay, next, vectors. So vectors can be represented on a diagram like so, or as a column vector. To represent it as a column vector, think back to translations. This vector is going 1, 2, 3, 4, 5 to the right, so that's going to be 5, and then it's going 1, 2 down. So this would be the vector 5 minus 2, and that's how I would write that as a column vector. Also, you may encounter questions involving column vectors. You might be told, for instance, A is equal to 3, negative 1, and B is equal to 4, 6. You might be asked to work out things such as 2A. Well, that means you just double those. That'll be 6 6 minus 2. Or you might be asked to find a plus b, and that means you just add them together, which would be equal to 7, because 3 plus 4 is 7, and minus 1 plus 6 would be 5, and so on. So you just work them out, and I like those column vector questions. And finally, you might encounter vectors on a diagram. So for instance, if we know that from O to A is equal to little a, and from O to D is equal to little b, if we want to find it from O to G, we would just do A plus A plus A plus B. So it'll be 3A plus B. And that would be the vector OG, because it's 3A plus B. And that's it. And that's it. So in this video, we've looked at angle facts. So the angles on a right angle will add together to be 90 degrees, and a straight line 180 degrees, at a point 360 degrees. If you've got two lines across each other, the opposite angles are equal to each other. They're called vertically opposite angles. Know your types of angles. So those are small acute angles, your right angles, your obtuse angles, the ones between 90 and 180, and the ones bigger than 180, which are reflex angles. Make sure you know how to measure and draw angles using your protractor. Obviously, make sure you've got your protractors. Just double check now that you've got it. Angles and parallel lines. Make sure you know that whenever you got angles and parallel lines, you might have lots of angles that are equal to each other, and know why they're equal. So your alternate angles. Some people call them Z angles, but make sure you call them alternate angles in the exam. Also, your corresponding angles. So for instance, the bottom left is going to be the same as the bottom left, top left, bottom right, top right, and so on. So make sure you know those corresponding angles, and also make sure you know your co-interior angles. So those angles will add together to be 180 degrees. Angles in a triangle add together to be 180 degrees. Angles in a quadrilateral add together to be 360 degrees. Angles and polygons, well, you just keep adding 180 degrees for every single side. So a pentagon will be 540, a hexagon 720, and so on. You can use the formula n take away 2 times 180. That'll tell you the sum of the interior angles. Also, make sure that you know that all the exterior angles will always add together to be 360 degrees. Also, the interior angles plus exterior angles will add together to be 180 degrees. And also make sure you know what the term regular means. So whenever you're dealing with a regular polygon, all the interior angles are all the same size, all the exterior angles are all the same size, and all the sides are the same length. Bearings, make sure that you can measure bearings. Remember, the bearings are measured clockwise from north, so you just measure the angle clockwise from north. Sometimes it will be a reflex angle, so make sure you know how to measure those as well. Make sure your bearings have 3 digits, so make sure if it's less than 100, you put a 0 in front of it as well. Also, make sure that you know how to work out back bearings. So you could draw a diagram, or if you've got a bearing that's less than 180 degrees, just add 180, and if you've got a bearing that's 180 or bigger, you just take away 180 degrees, and that'll tell you the back bearing. Know your compass directions, north, east, south, west, and also north, east, southwest, and northwest. Also make sure you know how to do scales and map questions, and make sure you look at the scale and make sure you know what that represents. In terms of perimeter, that's the distance around the outside of a shape. There for a rectangle, length times width. There for triangle, base times height and then half it, or half the base times the height, or half the height times the base. For parallelogram, just do the base times the height. The height's the distance between the two parallel sides, so it's not the diagonal, it's the height, that's the distance between the parallel sides. There for trapezium, that's a half the sum of the two parallel sides, so you add together the lengths of the two parallel sides, you half that, and then you times by the height, the distance between them. Area of compound shapes, make sure you split them up into smaller shapes and then find the areas of each of those. Units, make sure you know your imperial units and your metric units, and make sure you know your metric units in terms of converting them. Sensible estimates, make sure you know the lengths and masses and capacity of objects around you, and they'll be useful for your sensible estimate questions. Line symmetry, make sure you know your lines of symmetry and so on. Rotational symmetry, remember the order of rotational symmetry is how many times it lands on itself whenever you spin it through 360 degrees. Constructions, make sure you know all your constructions, in particular your perpendicular bisector and your angle bisector. Make sure you've got your compass and pencil ready for the exam as well. Loci questions, make sure you read those carefully and make sure you understand what you've been asked for as well in those questions. Your 2D and 3D shapes, make sure you know their names and also what faces, edges, and vertices are. So faces, they're the faces of the three-dimensional shape. Edges, they're the lines that join the vertices, and the vertices, they're your corners. Your nets, make sure you know the different nets of the three-dimensional shapes. Your parallel lines, so they're two lines that go in the same direction and never cross each other. Your perpendicular lines, lines that cross each other at 90 degrees. Views and elevations, make sure you can draw the front elevation, so that's the view from the front, the side elevations, and also the plan view from above. Time calculations, I find timelines can be quite useful for those. Timetables, make sure you're confident with your bus and your train timetables and things like that. Distance charts as well, make sure you can read those. Speed, distance, time, make sure that you know that speed is distance divided by time, that distance is equal to speed times time, and that time is equal to distance divided by speed. Travel graphs, you might need to work out the speed for particular parts of the journey. So remember the distance divided by time is your speed. Also, if it's a distance time graph and the graph is horizontal, that means the thing is stationary. Density, remember that density is equal to mass divided by volume. The pressure is equal to
force divided by area. Translation, that's where we slide a shape on a grid and make sure you know your column vectors. The number on the top tells you if it's positive to the right, if it's negative to the left, and how many squares to the right and left. The number beneath that would be how many squares up if it's positive, and if it's negative, how many squares down. Reflections, make sure you can reflect shapes in the x-axis, the y-axis, lines such as x equals 4, x equals -1, or y equals 3. Also the diagonal lines, y equals x and y equals -x. Rotations, make sure you get that tracing paper and you can rotate shapes on grids. Enlargements, make sure you can mark on where the center of enlargement is on a grid and make sure you can enlarge shapes on grids. Parts of the circle, make sure you know all the different parts of the circle, such as the arc and the sector and the segment and the tangent and the radius and the diameter and so on. The circumference, pi times diameter. The area of a circle, pi r squared. Make sure you can find the length of arcs, so for instance quarter circle, semicircle, things like that, and the areas of sectors as well. Pythagoras' theorem, a squared plus b squared equals c squared. Trigonometry, remember your two old angels skipped over heaven carrying a harp, or your SOHCAHTOA, and make sure you know how to do those trigonometry questions. Your exact trig values, they can be quite useful to know those as well. Similar shapes, remember similar shapes means an enlargement, so if you find the scale factor of enlargement, you should be able to find the length for the missing sides. Congruent triangles, remember congruent means the same shape and size, so with congruent shapes you might need to identify which shapes are congruent on a grid, but also for your triangles, remember your side, 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 your angle, side, angle, your side, angle, side, and your right angle, hypotenuse, side. Volume of a cuboid, length times width times height, and the volume of a prism, which is the area of the cross section, times the length. The volume of a cylinder, the area of the circle, times the length. The volume of a sphere and the volume of a cone, those formulae are given to you in the front, so make sure you know where they are and you can use them. And same thing for the surface area of a sphere and a cone. Surface area, make sure you get area of all the faces and add them up. And vectors, make sure you know how to represent vectors and also how to write them as column vectors and answer questions like that. So hopefully this has been useful for you.
And that's it. So we've gone through recaps of the number topics, the statistics topics, the algebra topics, and today we're going through the geometry and the shape system measure topics. So I really hope you find these recaps useful. There's obviously 2 days to go to your GCSE Maths exam, so these recaps will be really useful for you whenever you do that exam the day after tomorrow. Tomorrow's going to be our last video. I know it could shed a tear. I'm exhausted after making these 200 odd videos. But in terms of these videos, I really hope you found them useful. Tomorrow's the last video. I'm going to bring it out a lot earlier than the other videos. So I'm going to bring it out about 10 o'clock or 9 o'clock tomorrow morning. So keep an eye on YouTube for that last video. It's a good luck message for me, but also it's going to go through some tips in terms of your revision tomorrow and then going into the exam and just some tips for me on that. So I'll see you tomorrow for the last video, and thanks very much. Cheers. Bye.